Our next presenter tonight is Lindsay Thornton, a Master's of Science student in physics. Her presentation is All Optical Production of Metastable Krypton with Applications to Atom Trap Trace Analysis. And now I want you to repeat that back to me. Right? Yeah. Better known as Krypton dating, not just for Superman anymore. Lindsay's faculty mentor is Dr. Charles Sukenik.
When I say the word security, what comes to mind? Water security? Maybe not. Home security? Cyber security? But let's go back to water security. Water is absolutely vital to our survival here on this planet. So scientists and leaders need to know what's going on with the water around us. And they need to be able to date old water samples and polar ice because they can tell us what happened in the past. Are we using up our water faster than it can replenish itself? And what might happen in the future? To do this, we need to update our dating techniques. And if you take a look at the graph behind me, you'll see carbon-14 right in the middle. And I'm sure all of you have heard of carbon dating before. It's excellent for dating human artifacts, but you'll notice it's only reliable for a certain age range. But if we date using Krypton and argon, you'll notice we can cover a much broader age range. In fact, Krypton 81 can date back as far as 1.5 million years. Very impressive, but you're probably asking yourselves, why have I never heard of Krypton dating before? Well, that's because currently worldwide, only 2 labs actually Krypton date routinely, and they can only get through about 150 to 200 samples per year. Not very many. Why so few? Well, first of all, the technique they use is still fairly new. It's called atom trap trace analysis, which just means that they use lasers to cool and trap those krypton atoms so that they can count them. But before they do that, they need to excite those little atoms up to what we call a metastable state, which just means that those atoms are hanging out longer in that state than they normally would. Fabulous. Unfortunately, the apparatus that they use to create that metastable krypton requires 36 hours of cleaning before every single measurement. No wonder they can only get through a few samples a year. So my research is to build a new apparatus that gets rid of that 36 hours of cleaning and uses an ultraviolet lamp and lasers, so all optical. And if successful, if we tune it to just the right wavelengths, we can excite those krypton atoms to just the right states. And our apparatus can be sent off to improve ADA, and scientists all over the world will be able to date using Krypton, which means they can date farther back, more accurately, and will open up a whole host of possibilities for new discoveries.
Am I the only one who thought that Krypton dating was going to be a whole different thing? You know you did. What a fun presentation. So essentially what you're doing is shortening this cleaning process. I mean, you're right, that has a huge impact when you look at the quantity of scientific research you can do.
Yeah, 36 hours is an extremely long period of time, and so essentially we're replacing the front end of their procedure and speeding things up.
Well done. Lindsay Thornton, thank you so much.
Thank you.
Yeah, I thought she had a whole Match.com thing going there. I'm not going to lie. That's why they're doing this, and I'm just reading their names. Trying to, anyway.